Please read the following question. To determine the hybridization of a central atom of a tetrahedral, you will simply count the number of regions of high electron density. Even with a double or a triple bond, they all count as 1. These bonds are the number of orbitals in the molecule. So count all the bonds that are connected to the central atom, which is pink. You will find that there are 4 bonds to the central atom, so the hybridization of the central atom is sp3. The s orbital only has 1 orbital, the p orbital has 3, so when you add them all together you get 4, which is the number of bonds that we have. To determine the hybridization of a trigonal bipyramidal, you will do the same thing and count the number of bonds to the central atom, which is pink again. You will find that there are 5 bonds, which tells us that for a trigonal bipyramidal molecule, the hybridization is sp3d. And when you add all of the orbitals up together, you will get 5 to match the number of bonds to the central atom. We will do the same with the octahedral and count the number of bonds to the central atom, which is pink. The octahedral has 6 bonds bonded to the central atom, giving it an sp3d2 hybridization, which again, added all up together, gives you 6 orbitals that match the number of bonds to the central atom. For the linear molecule shape, you will count the number of bonds to the central atom, which is pink, and you will find that there are 2 atoms, giving it an sp hybridization. Please read the question. For these problems, we will do the same as we did before, but we will have to draw the Lewis dot structure before we find hybridization of the atom requested. So after you've drawn the Lewis dot structure, you can count the bonds to the atom it is asking for, which in this case it is the sulfur atom. And you just count the links to the sulfur atom and find that there are 6, giving it an sp3d2 hybridization. For this one, you will do the same, and you have to draw the Lewis dot structure. And it is asking for the first chlorine atom, which is the one on the left, and count the bonds, and you find that there are 4, giving it an sp3 hybridization. Do the same thing. You have to draw the Lewis dot structure and count the bonds and lone pairs, which will count as 1, just like the lines count as 1. So you have 4, and the nitrogen has an hybridization of sp3. For this one, we are finding the hybridization of the carbon atom, and you will count the double bond to the carbon atom as 1. So there are only 3 bonds to the carbon atom, giving it a sp2 hybridization.